Welcome to The Explainer. Today, we're literally dismantling everything you thought you knew about computer memory to look at the paradigm-shifting OMI relation frame. If you've been tracking new computation models, you know OMI is a total game changer. So let's jump right into the source material and see how it actually works. Here's our roadmap for today. First, not memory, but address space. Second, anatomy of the envelope. Third, the 8-tuple pedagogical scaffold. Fourth, unfolding the notation. And finally, movement becomes receipt memory. Let's get to it. All right, section 1, not memory, but address space. So we've got to unlearn a really deeply ingrained concept right out of the gate. When we hear RAM, we automatically picture these physical buckets just holding static data, right? Well, OMI is not a bucket. It's actually a circular, addressable relation space with bounded carry-forward services. So if someone tells you, hey, OMI has no memory, well, that's not quite right. But if they say OMI is memory, that's also wrong. It's something else entirely. The real sweet spot is this. OMI defines a circular address space first. Memory only shows up after movement through this address space is validated, receipted, and made replayable. It's an emergent property. It's a completely different foundational assumption about what computation is literally doing at its core. Moving on to section 2, anatomy of the envelope. Okay, let's zoom in on the physical structure at the byte level. This 512-bit envelope breaks down into exactly 64 bytes. Notice how we get 4 8-byte lanes: gauge, orientation, recovery, and target. Now, these aren't memory cells just waiting for random data. Think of them strictly as address or ruler surfaces. Then trailing behind that, you've got a 32-byte relation tail, which carries the actual payload, witness or pairing. Now, inside that structure, we map out specific relational pairs. Looking at the first 7 pairs, so 0x00 to 0xFF, they define strict boundaries and relation sides. We've got pair 0 as the gauge and source boundary, pair 1 the orientation boundary, pair 2 for recovery, pair 3 for target. Then pair 4 is the CAR relation side, pair 5 is the CDR relation side, and pair 6 is the cross-reference or witness side. It's like a giant, perfectly organized puzzle coming together. And here is why the 8th pair 7, is absolutely critical. This is the relation of relations, the closure side. It is definitely not just another storage slot you can cram data into. Actually, it's the keystone. It's the exact piece that lets those first 7 pairs be read as a cohesive, functioning relation, rather than just, a random string of isolated bytes. It essentially closes the circuit. All right, section 3, the 8-tuple pedagogical scaffold. Now that we've mapped the physical envelope, we can introduce the 8-tuple. This S0 through S7 address cascade is an incredibly helpful teaching tool. It directly maps the 8 fields onto a traditional automata 8-tuple. So you've got Q for state space, sigma for alphabet, L for left or source, R for right or target, delta for transition, S for start, T for accept, and R for reject. Pretty clean mapping, right? But, and this is a massive canonical but, straight from the source text's authority notice, you really have to listen closely here. The 8-tuple is strictly a pedagogical bridge. It is just an explanatory scaffold over the extended Hamming code. It is absolutely not the executing authority itself. It doesn't validate, it doesn't receipt, it doesn't execute or accept relation state. It's literally just there to help our human brains read the system. Basically, it exists purely to explain why OMI notation requires a specific hinge to make the folded relation inspectable. The system makes a hard distinction between deterministic closure and resolvable projection. The 8-tuple just conceptually bridges that gap so we understand why a perfectly closed loop still needs a way to be read by the outside world. Which brings us to section 4, unfolding the notation. Let's see what that hinge actually looks like in practice. OMI notation presents the relation frame natively. You can see it transition from this formal quantum-style citation kit on the left right into the compact folded root on the right, written out simply as lowercase OMI -- IMO. That right there is the folded root relation, the carrier itself. But to actually read it, we need the complete canonical alias. We have to append a tangential pointer, that question mark, capital O underscore lowercase o you see here. The question mark is our witness or query separator. The O underscore O is the F-column printable branch. When you put them together, they completely unfold that internal root circulation into a readable witness branch. Think of this hinge as a handle. Without it, the relation is just a hidden internal impression. This tangential pointer ensures that the incredibly high-dimensional carrier data projects safely back down to a lower-dimensional, readable surface. It makes the declared value referable. You're basically able to peek at the relation without destroying its closed circuit, which is just brilliant. And finally, Section 5, movement becomes receipt memory.
Let's pull this all together. How does this addressable relation space become what we lazily call memory? Well, it's a three-step consequence of validated movement. Step 1, movement through that 512-bit address envelope is validated. Step 2, the relation is receipted by the system. And Step 3, the movement is made replayable. Only after all three steps do you actually get memory. It's an outcome, for sure, not a storage bin. The source material highlights a profound philosophical shift from "in my opinion" to "on my intelligence." For a long time, this was just an opinion, a human observing patterns. But that completely changed when the relation became inspectable enough to close as a perfect circuit. As the text says, they didn't close as a cage, they closed as a circuit. It became a system that can actually stand behind the witness of what it noticed.
So we're left with this massive paradigm shift. If memory isn't a physical place we cram things into, but is actually the resulting receipt of validated movement through a perfectly structured 64-byte address envelope, man, what else about traditional computing are we ready to unlearn? It totally rewrites our understanding of state and relation. Thanks so much for joining me for this explainer.